Hello, good morning. Welcome to the information session on the master program Quantum Information Science and Technology. My name is Mirjam Blauboer. I'm the Director of Studies of this master program. And next to me, you see Nienke Penninga. She's the academic counselor. And both of us will present about this master program to you. First, we have some slides to show you. And then there is a question and answer session afterwards. And you're very welcome to send in questions already now or during the presentation. And then once we're done with the slides, we will look at all of your questions and try to answer them in this session as best as we can. So very welcome. This master program, what is it about? Well, quantum information science and technology is about understanding, investigating, and designing quantum information processing devices. And that's a very general term, but probably you've heard of quantum computers, quantum communication networks, quantum internet, quantum sensors. All of these are examples of applications of quantum technology. So this master is a specialized program that really focuses on this discipline, quantum information science and technology. And on the slide, you can see three beautiful pictures from our labs here in Leiden or in Delft, because this master is a shared master between Leiden and Delft, and Nienke will tell you more about that later on. So you have an impression of the labs that we have in our two universities. First, a few general remarks about the master. The QUIST, Quantum Information Science and Technology, is a very new program. It started this academic year, about a month ago, early September, with the first generation of students. We have a picture of this first generation later on in the presentation. We started with 20 students. So you, listening in, might be the second generation for this master. I already mentioned that it is a joint degree between two universities, Delft University of Technology and Leiden University. If you are from the Netherlands, you probably know the two cities. If you are not, they're geographically not very far away from each other. It's about a train journey of 15 minutes between the two cities. QUIST is also a multidisciplinary master program, unlike many other programs that I could imagine you're also interested in. So multidisciplinary means that it admits students with different bachelor diplomas. So if you have a bachelor from either physics, mathematics, computer science, electrical engineering, or astronomy, you are eligible for this master program. And there are some additional admission requirements, such as having done 5 EC courses on a quantum-related subject, and a bachelor research project. And all of those specific admission criteria you can find on our website. The curriculum. If you choose this 2-year master program, what will you be doing? Here you see the program in a nutshell, in a schematic on the slide. So the upper half is year 1. We're reading from left to right, going through the various quarters. Q1 is the first quarter of the year, then Q2, and so on. And the lower half is the second year. And roughly speaking, in the first year, you'll mostly be doing courses, coursework, exams, but also a 5 EC project. And in the second year, you'll almost only be doing projects, a team project and your master's thesis project. And I will go and describe the various elements in the slides after this one. But generally speaking, you'll be spending the following percentages on the different elements, and the color coding also relates to these elements. So there's coursework, which is given in purple and in blue-green and in the bright green. All those boxes are coursework. Then there are multidisciplinary team projects for about 17% of your time, and then 37% of your time will be devoted to your thesis project, and that's in the second year. So the majority of the master is coursework. So let's look a little bit more in detail at the 2 years. Here you see a pie chart of the first year. Again, the color coding is the same. So there's a purple block that is called homologation. I'll explain what that is in a minute. Then there is a blue-green block on core courses. Those are courses that are compulsory for every student in the program, 20 EC in total. Then there is a large bright green block on electives. Those are courses that you can choose. We have a long list of courses that you can choose from, and they also relate to the different disciplines of students that come together in the master program. So there's courses that are from physics, there's courses that are specializing in math, courses from electrical engineering, computer science, and so on. So a lot of freedom to choose electives in the green block. And then there's one project, a team project, 5 EC. It's right at the beginning of the program, where you will be teaming up with other students who are from a different bachelor than you yourself, and you'll be given an assignment that relates to quantum technology in some way, and work on that for part of the first quarter. I'll also tell a little bit more about that in 2 slides from now. So this is the first year. As promised, mostly courses and 1 team project, small team project. And in the second year, it's almost the reverse. There is no coursework, or very little coursework, depends a bit on which master thesis direction you choose. But mostly it's a team project, a larger team project this time, 15 EC. And then there is your master's thesis project, which is an individual project, 44 EC. And there's a very tiny part of the chart in bright blue, which is called portfolio. And that is the time you'll be spending on learning about transferable skill, and not learning, but mostly practicing transferable skills, like learning how to present, how to work in a team, how to organize yourself, but also learn about ethics related to quantum technology, dilemmas that could come up in society when you develop quantum devices. So that part we call portfolio or equip. And now it's here in the pie chart of the second year, but actually this portfolio is running throughout the 2 years. In small teams throughout the 2 years, you'll have regular moments as a team with a mentor to reflect both on your personal skills and also on elements like ethics and legal aspects related to quantum technology. So, that was very broadly speaking. Please also send in questions if you would like to know more or more details. I will now go through the various parts of the curriculum in a little bit more detail. And again, if that still leaves questions with you, do not hesitate to send them in. So the purple box in the first quarter, called homologation. Homologation means establishing common ground. So in that first quarter, you will follow an individual learning path. And by that, I mean that the quiz program offers modules on different topics. Some are more physics-like, some are more electrical engineering-like, and you choose from those modules the ones that you need, the ones that you didn't have a lot of coursework on during your bachelor program. So if you have a bachelor in physics, you will typically do modules on quantum information theory, you will do a module on electrical engineering circuits, and you will do a module on advanced mathematics. If you come from electrical engineering, let's say, in the first quarter, homologation, you will do something on quantum physics, because that's probably something you didn't learn much about in your bachelor program, and also do quantum information theory and computer architectures, and so on. If you come from computer science, you again choose your own set of modules with the idea that by the end of the quarter, having gone through these modules, All of you, regardless from which bachelor diploma you come, will have the same knowledge, the necessary knowledge to enter the core program, to do the core courses together. The reason we do this is because it's a multidisciplinary program. You'll be working together with fellow students who come from a different discipline. So to establish common ground, you have this individual program in the beginning. The method by which we teach this is mostly flipped classroom. And probably you've heard the term. That means that a lot of the theory material is available online, either in the form of videos or an open book or some other way in which the material is distributed. And you mostly come to campus for problem-solving sessions, question and answering sessions with the lecturers. Flipped classroom. So that's homologation. Then after homologation, in the second quarter, the core program starts. And we have within the quiz program 5 compulsory courses that you have to do. Every quiz student takes them. And they're listed here. But what they're inspired by is by this stack-like structure that you see in the bottom right corner. And by that I mean that every application, quantum technology application, can be represented as a stack. Now here schematically you see the stack scheme for a quantum computer, but also a quantum network or a quantum sensor you could represent in a similar way by means of a stacked structure which has various elements. And the aim of the core program is to take you through all the various elements that comprise the stack. So at the bottom of the stack, typically you'll find the hardware, the qubits, the quantum processor. So that's very physics-like. You'll learn about hardware in the course Qubit Dynamics and Quantum Control. Moving upwards, there's the readout electronics and the microarchitecture. That is more related to electrical engineering knowledge. So there'll be two courses that teach all of you, that deepen your knowledge on devices and interfaces and on architectures, quantum architectures specifically. Again, moving further up, there's the compiler and then the quantum programming language and the algorithm that you can actually run on a quantum computer. And the 2 upper courses teach you about that. There's an introductory course, the fundamentals of quantum information, that I happen to teach myself at the moment, that gives you an introduction to all of these elements in the stack. And then we have a dedicated course on quantum computation and quantum programming, where you will actually learn how to write a quantum program and how to run it on such a stack. So this is the stack for a quantum computer, but also quantum networks and quantum sensors can be represented in this way, and all of these applications will also be discussed in the various courses. So after the core program, the idea is that you have a very broad and good, deep knowledge about what it takes to build, to design, to build, and to investigate a quantum technology device. Now, after the core, you choose your elective courses. I don't have a slide on that, but I think it's familiar to all of you, and please ask if you would like to know more. Having gone through the core program, you can choose in which direction you would like to specialize. But first, we need to talk about the team projects, because so far I've been talking about coursework, but we also have 2 team projects, and you see them encircled in yellow here in the curriculum. There's a small project at the beginning of the first year, and there's a larger team project at the beginning of the second year. Now, the first project, both of them are in teams with students who have a different bachelor diploma than you yourself have. And you will work in the first smaller project on, it could be a more theoretical or a more practical problem, but it does involve a quantum technological problem. And in the second year, this will be repeated, but the problem will be much more challenging. And a big difference is that it will be supervised and also be given, suggested by industry. So in the second year, you'll spend the first quarter full-time in collaboration with a supervisor from a company who has suggested a highly challenging problem that this company faces and that relates to quantum system integration. And you'll be able to work on that because you've gone in the first year through all the theory and the background that you need in order to tackle this problem in the second year. These type of projects have been offered in Delft for a while now, and they are very popular by students. They're also very successful in the sense that in 10 weeks, 1 quarter, such a team of students generally manages to really present an interesting and original solution pathway for the problem. Not always a full solution, but at least they make progress, and also the industry is often very happy with the results. So that's the 2 team projects, one in the first year, one in the second year. And then it's perhaps hard to see, but the bright blue ribbon, that's the portfolio part of 1EC that I mentioned a little bit earlier. You see that it runs throughout the 2 years, and this is a dedicated time in the curriculum where you reflect on your personal skills, but also on societal, ethical implications of quantum technology under the guidance of a mentor. Small groups plus a mentor assigned to each group. Now, one last slide about the content of the program, and then I'll hand over to Nienke, who will tell you more about student life and the 2 cities and what you could do later on as a profession when you choose this master. But first, still something about the choices you can make during the program. So the core program is compulsory, but after that, you can choose electives, and you also have to choose a profile after the 2nd quarter. Yeah, so the red arrow up there indicates the end of the 2nd quarter, and at that moment in time you choose a profile. And we have a choice of 3 profiles, and they are inspired by the 3 application areas of quantum technology. So one application area is in computing, quantum computing and simulation. Another application area of quantum technology is more communication, networks, quantum internet. And a third area of specialization, application, could be sensing and metrology, developing quantum sensors that are super sensitive and can measure in a much more accurate way than classical sensors can. So you choose a profile depending on which application interests you most, but the profile is very loosely defined. It doesn't restrict you much. Yeah? It only means that you have to choose a certain elective that is attached to the profile that you choose, but otherwise you're still very free to choose your own set of elective courses. And the idea is that you will also, in the 2nd year, choose a master thesis project in a group, a research group, either in Leiden or in Delft, that relates to this application area. So if you choose the profile quantum communication, you could, for example, work on developing quantum super dense coding protocols in Delft with a group that does that work there. So the master thesis project in the 2nd year is large, takes up 3 quarters of the year, Q6 to Q8. And there again, you can not only choose which application you want to work on, so that's more content related, but you can also choose which nature your master thesis should have. And there's a choice of 2 there. You could do a research or design-oriented master thesis project. Well, you'll be spending the project in one of the research groups, in either in Leiden or Delft, or you could choose a more business-oriented master thesis project. And then you'll work on a project which could be in collaboration with industry, and you'll also follow some business courses on the side. So that's my part related to the content. I'll now hand over to Nienke, who will tell you more about job prospects and student life in the 2 cities.
Thank you, Miriam. Okay, let's look at the career prospects. Of course, we don't have any graduates yet, but of course we did some research before we wanted to start this program, and the job prospects for quiz students are expected to be very good. If we look at the job prospects of graduates from the TU Delft, about 80% of them have a job within 3 months of graduating, and we expect quiz students to have the same possibilities. So where will you find a job? You can go different directions. You can go into research and development, for example, in one of the many quantum-related companies around Leiden and Delft. Also some start-up companies, those are of course smaller, but also large companies as Microsoft, ASML, Atos, Google. Then you can go into consultancy or management, of course, the technical bit, but also the more general consultancy bit. You can go into education. We have an education program at TU Delft and also at the University of Leiden. And excellent students can choose to pursue a PhD degree if they want to. And there are some dots, because we don't know where other people can go to. And you can also find your own career path. So you can choose QUIST if you would like to find work at the forefront of developments in quantum and technology. And we listed some companies on this slide. As Miriam already mentioned, you will have courses at 2 different universities, because QUIST is a joint degree between the TU Delft and University of Leiden. We just picked 2 pictures. One from the Bioscience Park in Leiden. This is a new building where some of our lectures are being held. On the left, and you can see already it's on the forefront of development in quantum field. And on the right, you can see the campus in Delft. This is the large building of mathematics that you can see in the back, but there are more buildings and more facilities on the whole campus. In general, you will spend about 3 days per week in Delft and 2 days per week in Leiden, which means that you have to travel. So that also means that it doesn't really matter where you choose to stay to live, because you have to travel anyway. Traveling between the 2 cities is very easy. There's a train connection which goes several times an hour. It only takes 15 minutes, and then you have to cycle a little bit. So most of our students have a bike at either location to cycle into to the location, and there are also buses going. So it's very easy to reach the different locations. So what is student life? What does it look like? Well, you have student life in both of our cities, so in Delft and in Leiden, because you are a full student at 2 universities. So you can also have 2 cities to discover. So student life is twice as large, which I think is good. We also have 2 students' associations. The Leidse Fles is located in Leiden, and the Vereniging voor Technische Physics is located in Delft, and they have a master's group. It's called ASAP, and you can also do several things with them. They organize informal meetings, they organize trips, parties, but they also organize career events where, for example, you can speak to graduates of, well, for now, different programs, and have a networking event, for example. You can also make use of 2 different university sport facilities, and just in case you might need some help during your studies, we also have 2 teams of student psychologists and student counselors. The counselors can answer questions about, for example, financial things, etc. So 2 cities and 2 opportunities to develop yourself, because besides the sports facilities, there are also cultural facilities and other things, of course, you can do as a normal student in a normal city. So is QUIST a good option for you? Yes, if you have specific interest in quantum science and technology. As Miriam already said, a prerequisite is a bachelor degrees in physics or applied physics, mathematics or applied mathematics, computer science, electrical engineering or astronomy. But you do need 5 EC on quantum-related courses on a good level. And you need a bachelor research project of at least 12 EC, so that's about a quarter of the year. So you already mentioned that we started with 20 students. This is our cohort that is currently working together in different project groups, doing the homologation course, and we'll go into the more specialized courses later on. We have a nice mix of all the different prerequisite programs, and we also have a nice combination of international students and Dutch students. And we hope for coming year that we will have the same thing, and hopefully the group will be a little bit larger. So next year we will have such a picture, maybe you are on the picture. So some practical matters. Registration for quiz opens on the 15th of October. Registration goes via StudiLink, that's the Dutch system to register for programs. More information on admission criteria, the things that we already listed, is on this website. And because it might be quite hard to just write it down, scan the upper QR code and it will take you to this website. If you have any questions after this session, and we will just after this slide, we'll go to the Q&A bit of this presentation. But if you have any questions afterwards, please contact my colleague Eva. She is the program coordinator. And you can also contact me, I'm the academic counselor, via the emails that are listed here. And the lowest QR code you can use to book an online meeting with me. You will go to a website there and you can select a time, a date and a time, and you can have a meeting with me. If you want to have it online, please state so in the free form field, so I know that I have to send you a Teams link. What kind of questions can you ask us? For example, Eva, you can ask questions about, am I eligible for this course? Because I have a slightly different program that you've listed before. And you can ask me questions about, I've had personal problems, for example, in the past. How do I combine these with my studies? Or, for example, I have ADHD or ADD, or I have special requirements to do the course, to do the program. For those things, you can come to me, and for that, you can scan the QR code or email me.